Hello class, these are our notes for section 212. This is polynomial division, factoring using a box diagram. So first section here, we're looking at finding factors based on zeros. So if p of x equals, and then we've got a polynomial here, x cubed minus 5x squared minus 2x plus 24, and p of negative 2 is 0, we can conclude the following. The point negative 2, comma 0, right, because this is my x, this is my y, must be on the x-axis as an x-intercept. And what that also means is that negative 2 is a 0 of p of x. And lastly, that x plus 2 is a factor of p of x. So first, this is just like using the notation. Let's think about what this means. So let's look at this again. So p of negative 2 equals 0. That means if I input negative 2, my output is 0. So as an ordered pair, that's negative 2, 0. Since the y value is 0, we know it's an x-intercept. We know it is a 0 of p of x because it's a solution to making this whole thing equal 0 here. And we also know, kind of working backwards, that if we have a negative 2 as an x-intercept, then x plus 2 is a factor. So if we can factor p of x equals x cubed minus 5x squared minus 2x plus 24. So if we can factor p of x, the factored form must look like p of x equals x plus 2 times something. And as such, that whole polynomial must be x plus 2 times something. To find the unknown factor, we can divide both sides by x plus 2. So just like if I have, I don't know, like 48 equals 6 times something, right? And I don't know what that is. I can divide both sides by 6. So it's the same idea here. I don't know the something, divide both sides by x plus 2. That's all they're saying. And so what that means is we would take that entire polynomial, x cubed minus 5x squared minus 2x plus 24, and we want to divide it all by x plus 2. And then we're going to talk about how to do that. But first I want to just delete these guys. I don't like the way that looks there. It's kind of messy. We'll get rid of this one too. That way when I scroll it back at the end, I remember what I'm doing. So as we scroll down the page, we're going to talk about our first long division method that we're getting today. And we're going to be dividing polynomials working backwards using our box method. So this is kind of how we're going to be filling this out. We're going to be solving it backwards, and we're really doing that on the next page. So this is just like setting it up. Basically, because we have x cubed, we're going to need 3 columns. And so we have 1, 2, 3 columns. The factor we're dividing by, the x plus 2, will go over here, and we'll end up starting with x cubed in the corner, and we're just going to kind of work it through backwards. So let's go ahead and look at this next page. So this is what we're set up to divide. And I'm going to do exactly what I said. I'm going to make a box with 3 columns. And because I am dividing by x plus 2, I only need 2 rows with an x and with a 2. So 3 columns because it's cubic. I'm going to start with x cubed right here. One thing that we want to do is if there's any zeros, like if I had an x cubed term but not an x squared, I'd want to put a 0x squared in there. So fill in any zeros. No x squared term, include 0x squared into the polynomial. We don't have that here, okay? Set up the box with a known factor on the side. That's our, sorry about that, x plus 2. We're all set there. You need as many columns as the degree of the polynomial. And we're going to enter the leading term in the top left box. Okay, the rest of this I feel like is really weird. I'm going to kind of walk you through it, and then we're going to fill out the blanks. But I have actually a hard time following this. So what I do is I go through and I kind of do what I can. So if I know the x cubed is right here, then my next move is to fill out this box. So, or sorry, above this box, because I know that x times this thing have to multiply and make x cubed. And so that's going to be an x squared. Okay, now I want to move down here. And if I have a 2 right here and an x squared right here, I can now fill in this box. So that's going to give me a 2x squared. All right, now I know that the way this box method works is I know that these two are going to always add together to make that x squared term, right? That's how this works. So I want to look at my x squared term in my problem, and that is a negative 5x squared. So 2x squared plus something else needs to make negative 5x squared. So then I can tell this has got to be a negative 7x squared. And then I just double check it. 2 plus negative 7 makes negative 5x squared. Okay, now that I've filled that out, now I want to go back up at the top again here. And I'm going to fill out this one. So if this is an x and this is a negative 7x squared, this has to be a negative 7x. Because when I multiply those two together, I'm back at the negative 7x squared. Okay, now we're going to go down here again. 2 and negative 7x. That's going to be negative 14x. And then I'm back to putting these two together to get my x term, and that's a positive 2x. So if I have a negative, actually no, it's not, there's a minus there. So if that's a negative 2x, then I have to have a negative 14x and a positive 12x, because those are going to make negative 2x. I feel like I want to color code this maybe a little bit better. I'm going to go ahead and color code this one for the purple diagonal. I'm going to erase that here. And then my last step is figuring out this last column. So if I have x and 12x, this is going to be 12 up above. And then down here I have 24. And is 24 the number I want to have? It is. There's a plus 24. So check 24 equals 24. It divides perfectly. So this means that I have an x plus 2 times an x squared minus 7x plus 12. Those multiply together. So let's fill out the stuff here, and then we'll go back and make sure we understand what we did. So figure out box entries one at a time by dividing to top row outside the box, multiplying top, I don't even really know. Like, it makes sense to me filling it out, but this just seems like a lot of words. Diagonals need to have like terms that add to the original polynomial terms. That's what we did with the diagonals that we circled, right? We circled those diagonals, we circled these diagonals to make sure they added to the like terms. If the last box entry is not the constant term, either a mistake was made or the given factor was not actually a factor of the polynomial. It did not evenly divide. We had a remainder. Okay, so let's just kind of stop here for now. So what this means is that I have my p of x equals, and my original was x cubed minus 5x squared minus 2x plus 24. And then I factored this into x plus 2 times x squared minus 7x plus 12. So what happened here was I know now that these two, when I multiply, give me back the original. I knew that x plus 2 was a factor. I used division to figure out what was left over. Now I could keep dividing. And what I mean by keep dividing is really keep factoring. So let's think about what multiplies to make 12 and adds to make negative 7. That's going to be negative 3 and negative 4. And now we have p of x fully factored. So when I look at this, I can figure out my zeros. Sorry about that. I have no idea what I'm pressing that's suddenly doing that. So I've got my zeros. My zeros are going to be the negative 2 and the 3 and the 4, or I could say my x-intercepts are negative 2, 0, 3, 0, and 4, 0. So let's remember x-intercepts are literally where I'm substituting a 0 in for all of this p of x, and I'm solving, okay? And I'm using zero product property. That's what an x-intercept is. That's where those numbers come from. So the last step was just trying to factor, keep factoring if the degree is greater than 2. And then if asked, you could determine zeros or x-intercepts. Okay, so we're going to try a couple more. Don't worry. This is a lot to take in right away. It's kind of like a puzzle, though. It's that part of math we like. We like the puzzle part of math. Using a box diagram, we're going to divide f of x by x plus 1. So this is cubed. I have x cubed, x squared, x, and a number. So everything looks good there. Since my highest power is cubed, I want to make a box that has 3 columns. X plus 1 is on the outside, so we're going to need 2 rows, 3 columns. All right, x cubed is going to go right here. So first we fill it above this by dividing. So x divides into x cubed, x squared times. And then I multiply back the 1 and the x squared to figure out what goes here. And that's going to be x squared. Now I know that these two that are diagonal to each other have to combine to make negative 8x squared. So I'm going to have to put a negative 9x squared right here. 1 and negative 9 would equal the negative 8x squared. Okay, now looking above this column, x divides into negative 9x squared, negative 9x times. Those two would multiply back to make the negative 9x squared. Now I've got to fill out this little box right here. 1 times negative 9x is a negative 9x. Okay, now I'm looking at this diagonal, and I want it to make 11x. So that means I need a positive 20x. 20x minus 9x makes 11x. We're good to go. Now I look at the top of that column. So 20x divided by x would just be 20. It's positive. And then down here, 1 times 20 is 20. That checks with what I want. 20 equals 20. It divides evenly. So all we had to do was divide this by this. So what we're really doing is we're saying take x cubed, minus 8x squared plus 11x plus 20. We're dividing by x plus 1. And it's equal to x squared minus 9x plus 20. All right, let's look at the next one. So on the next one, and do I have another zeros too? Just looking to see what we got going on here. So I think number 2 would be a really good one for you to try on your own. 3 is a little bit trickier. So go ahead and try number 2. Do be careful because it says x equals 3 is a 0. So that means my factor is x minus 3. So knowing that's the factor, go ahead, see if you can do your backwards box method, and then unpause it and check your answer with me. All right, so hopefully you tried this problem on your own. It's cubic, so I still need 3 columns. X minus 3 is the factor, so an x negative 3 goes outside the box. We need 2 rows. I start with 2x cubed right here. 2x cubed divided by x is 2x squared. I could also think x times 2x squared equals a 2x cubed. So I could either think like, what do I need to multiply there, or I could think division. Down here, I would have to multiply the negative 3 and the 2x squared. That's negative 6x squared. And now I've got to look at this diagonal, and I want this diagonal to make a positive x squared. So that means I'm going to put a 7x squared right here. Okay, now above it, that means I'm going to have a 7x. And then down here, I'm going to multiply again. Negative 3 times 7x is a negative 21x. Okay, now I'm looking at this diagonal. This diagonal needs to make a negative 18x. So if I have negative 21 right now, I need to have a positive 3x. When I add those together, it makes negative 18x. Now x divides into 3x 3 times. And then negative 3 times 3 would make negative 9. That checks with my original. So now we want to write an equation for g as the product of linear factors. So we're using this one to factor. And I really want to fix this exponent right here. That is a 2. So far what we have g of x equals x minus 3 times 2x squared plus 7x plus 3. Now I've got to keep factoring. So I'm going to use a different box for the 2x squared plus 7x plus 3. So 2x squared, 3. I don't know, that might be a cube right there. Not really sure what I wrote. 2 times 3 is positive 6. We're looking for things that multiply to make 6, but add to make 7. That's a 6x and a 1x. And then we're going to factor, so this row would be a 2x, 1x, 3. So we have a 2x plus 1 times an x plus 3. So now our g of x is fully factored. Then we want to find our x-intercepts. So our x-intercepts are going to be 3, 0, negative 1/2, 0, and negative 3, 0. Lots going on in this problem, huh? All right, for number 3, we know that negative 1, 0 is an x-intercept of f of x equals x to the 4th plus 3x cubed minus x squared minus 3x. Use the backward box method to factor f of x, then fill in the information and draw a rough sketch to graph it. And the graphing part is on the back. So first thing I notice is that my powers go down, but all of them have x. So I'm going to take f of x and I'm going to factor out an x first thing. And that's going to simplify what I'm working with. I just want to do a quick check. All my signs are right. X cubed, squared, x number. Okay. And so if I know that negative 1, 0 is an x-intercept, that means my factor is x plus 1. All right. So I'm going to take this part right here and I'm going to divide it by x plus 1. I'm not going to use the whole thing. I'm going to leave that x factored out. It's going to make my math easier. So x, 1, 2 rows. Highest factor is 3, so 3 columns. We're starting it with x cubed. So this is an x squared. Multiply it back down here. We have an x squared. And then these two in this diagonal have to add and make 3x squared. So I'm going to have 2x squared in this box. 2x squared plus 1x squared makes 3x squared. All right. Now above here, x divides into 2x squared, 2x times. And now for this entry down here, 2x times 1 is a 2x. Now we are looking on this diagonal. So 2x plus something has to make a negative 1x. So that means I have to have a minus 3x. All right, that means x, negative 3x. We have to have negative 3 up above here. Down here I would have negative 3. 1 times negative 3 is negative 3, and that checks. So now I'm going to keep factoring. So f of x is going to be x times x plus 1 times x squared plus 2x minus 3. We got to keep factoring because our goal is graphing here. So x times x plus 1. Let's see, multiplies to make negative 3. Adds to make positive 2. So plus 3 minus 1. All right, so now we've got a 4th degree polynomial. Let's go ahead and shrink it down for our graphing here. I'm going to write it. Maybe I'll just go through and figure out what this stuff is. So when I'm looking at my x-intercepts, if I have this x, it's going to be 0, 0. X plus 1 means a negative 1, 0. X plus 3 means we have a negative 3, 0. X minus 1 is a 1, 0. And because these are all first power, right? None of them have exponents, so it's understood they're all first power. We're going to cross at all of them. And if I think back to the original, if I put 0 in for all my x's, 0 to the 4th plus 3 times 0 cubed minus 0 squared minus 3 times 0. When I put a 0 in for x, I'm going to get a 0 out for y. So my y-intercept is 0, 0. My leading term was x to the 4th power. And really what I need to know is I need to know my degree, which is 4. And was it positive or negative? And it is positive. So I know my graph shape's going to be like this. Something like that. Both ends are up. So positive infinity for my end behavior. So now I'm going to start over here. I'm going to have to cross at negative 3, 0, at negative 1, 0, at 0, 0, at 1. So it's going to have to go down and back up and down and back up. And I don't know exactly how deep to make the valleys or how high to make the peaks. We just don't know. So it's kind of unknown how low to draw the valleys or how high to draw the peaks, but we just do the best we can. And that looks great. We've got the graph shape we want there. So I really like we started out by just doing this box method, but then we did so many things with it. We used the box method to show a division problem. We used the box method to show we could further factor, I can't say it, and find our x-intercepts. We use the box method to keep factoring and do a graphing problem. So the big skill that we're getting today is we're still working on our vocab, reading through these questions and understanding what they're looking for. But being able to divide with the box method is what we're looking at today. So as always, if you need help, please make sure you ask.